Hey guys, Mr. Balmer here with a review of conservation of energy problems in physics for you. We're going to go through the first three problems in your review for your test coming up this week. These first three are pretty straightforward. They're asking you about the different types of energy involved. One is about kinetic, one is about gravitational potential, and the other is about elastic potential or spring potential energy. This should be pretty straightforward. Let's take a look. Number one is one about kinetic energy. For each one of these, I've already written the equation for you that's associated with each one. What I'm really asking you to do is go into the problem, go into the text of the problem, and identify your variables. So in this case, you're given a velocity, you're given an amount of kinetic energy, and you're asked to solve for a mass. So it's really looking for you, do you know what the values are and how to plug them into your equation? So let's start. We already have an energy for this first one. It's 350 joules. We know the equation's 1/2 mv squared, so that's 1/2. We're looking for the mass, so I'm putting in m, and I'm going to put in 10 for the velocity, and that's going to be squared. Don't forget to do the squaring first in your calculator to make sure that you're putting it in the right place and you're following order of operations. If you go and solve for m, that's going to give you 7.0 kilograms for the mass. In the second question, this was asking you about a spring. This is asking you to find the spring constant. The spring constant, remember, is K. Let's take a look at the values that are in this equation, or in this problem. It gives you 45 joules of energy. That's going to be our energy. And a compressed spring, the amount of compression is 13 centimeters. Let's remember that this has to be in meters, right? The amount of compression is x, and 13 centimeters in meters is 0.13 meters. So let's substitute into our equation. 45 joules of energy is equal to 1/2 times the spring constant K, which is what you're trying to find in this case, times the x, which is 0.13. And again, it's squared. You're going to have to do that squaring first to get the correct answer. And when you solve for the K, you get 5,325 newtons per meter. That's the correct unit for the spring constant. Last one is gravitational energy. In this case, we're looking for the gravitational potential energy. The gravitational potential energy is our EPG. You're given a mass, and you're given a velocity, and you're also given a height above the ground. Well, if we're going to look at our equation, the equation tells us that we need mass times g times height. Well, the mass is given to us as 0.65 kilograms. You're given g, well, you know what g is. G is 9.8 meters per second squared on Earth, times the height, which is 6 meters. Now, you might be tempted to go back and put in this 10 meters per second, but we don't need a velocity. We're finding gravitational potential energy. So that's a little bit of a distractor in this question to make sure you are getting, or you're doing what needs to be done, and you understand what is an important value and what's not. So if you do that math, it's going to give you 38.2 joules of energy. So here's a straightforward one, 1, 2, and 3, and we'll come back with some conservation of energy ones and work energy theorem ones in the next episode.